let's take another look at comparing rational numbers. Before we do that, just in general, reminders of our inequality symbols. Less than is to the left, so I think of L for left, and when I turn that, it turns into the less than sign. Versus the opposite would be to the right, which is greater than, and when I turn that, that gives me the greater than sign. So as you go to the left, numbers are smaller, that's less than. As you go to the right, numbers are greater than, or bigger, that's greater than. So we're gonna go through the same method for each one, but specifically right now, we're gonna look at ones that have different signs. So the first question, every single time that you should be asking yourself is, do they have different signs? So I'm just looking at here, I see a negative sign. Here there's no sign, which means it's positive. So we have a negative and a positive, which are different. So yes, as soon as we know they are different signs, I do not have to look at the whole numbers. And all that I need to do for my work is notify and write that 13 is negative and 6 is positive, because that's all that matters when comparing positives and negatives. So negative 13 is a negative. A negative is always going to be smaller than or less than a positive. So less than is to the left. Turn our hand, that is the less than symbol. Number 2, we have 70, which is a positive, and negative 80, which is a negative. So we have different signs, yes. So we can skip question 2 about the whole numbers. In our work, we're just writing, we have a positive versus a negative. So a positive, 70, is always going to be greater than a negative. So greater than is on the right. Turn our hand, that is our greater than symbol. 70 is greater than negative 80. Number 3, negative 12.75, positive 4.8. Don't get tripped up by the decimals. We automatically see they have different signs, so I don't even need to look at my whole numbers. So my work is that we have a negative compared to a positive. A negative 12.75, is always going to be smaller or less than a positive 4.8. Less than is to the left. Turn our hand. That tells us the inequality symbol. And one more with fractions. Sometimes we see the fractions and right away think we need to start doing the work. Here we have a positive value. Here we have a negative value. So we have different signs. I don't need to look at the whole numbers. I'm just comparing the positive to the negative. A positive value, positive 17 and 5/6, is always going to be bigger than a negative. Greater than is to the right. This is our inequality symbol. So that is when they have different signs. Let's look at when they have different whole numbers. So we are just looking at the whole number. And that is whatever's to the left of the decimal or to the fraction, the whole number part. So here we have 2 decimals. I'm looking to the left of my decimal here, okay? But I'm still gonna first ask myself, do they have different signs? So we have a positive and a positive. So unlike before where we had opposites, these are the same, so we can't just compare and say, oh, a positive is bigger than a negative or a negative is bigger than a positive. So that first question doesn't apply, which is why we have to go to the second question, which is, do they have different whole numbers? So we have positive 3, positive 25. So those whole number values are different. What that means is I don't even need to look at this decimal value because the whole numbers on their own can be compared. We have 3 and we have 25. It would be like saying you have $3.12 compared to $25.10. The 3 and the 25 are all you have to compare. $3 versus $25. 3 as a positive is smaller than, it's less than 25. Less than is to the left. Here is our inequality symbol. Again here, don't start working with the fractions yet. Do they have different signs? We have a positive and a positive. So no, we can't use that to compare. Now let's look at our whole numbers. Remember, the whole number is the number next to the fraction. So we have 5 compared to 1. So yes, those are different. That is all that I'm doing for my work. I don't even need to look at these fractions. I'm just looking at the whole number 5 and just looking at the whole number 1. So 5 is greater than 1. $5 is more than $1. 5-year-old is older than a 1-year-old. So our inequality symbol, greater than, is to the right. Our symbol looks like this. Okay, 2 more like that. Looking at our signs, we have a negative and a negative. So no, they aren't different. They are both negatives. Can't use that to compare. Do they have different whole numbers? Well, we have negative 17 to the left of our decimal. We have negative 5 to the left of our decimal. So yes, those whole numbers are different. I'm ignoring what's to the right of the decimal. I'm just looking at negative 17 and negative 5 when I'm comparing. Those decimal values aren't going to matter here. So if these were positive, 17 is bigger than 5. A 17-year-old is older than a 5-year-old. $17 is more than $5. But they're negative, so they work in the reverse. So positive 17 is bigger than 5, but negative 17 is less than negative 5. Negative 17 degrees would be colder than negative 5. It's further into the negatives. So less than is to the left. Here is our inequality symbol. And one more like that. We have a negative and a negative. So no, the signs are not different. Do they have different whole numbers? Well, that's the number next to the fraction. We have negative 2 and we have negative 10. So yes, we have different whole numbers. Negative 2 and negative 10 is all that I'm comparing. If they were positives, 2 is less than 10, right? A 2-year-old is younger than a 10-year-old. $2 is less than $10. But since they're negatives, it's the opposite. Negative 2 is going to be greater than negative 10. Greater than is to the right. Here's our inequality symbol. So the last one, these ones are the hardest. And we put a little refresher up here again for the inequality symbols. Okay, but ones that have the same signs and the whole numbers, that means we actually do have to look at the decimal and fractional parts. Okay. So we're going to compare negative 5.4 with the bar over it and negative 5.4. So first thing, do they have different signs? I have a negative and a negative. So no, they do not have different signs. So we got to move on to the next question. Do they have different whole numbers? Well, to the left of the decimal here, we have negative 5. To the left of the decimal here, we have negative 5. So no, they don't have different whole numbers. So I'm going to rewrite my decimals as is, and I'm going to make sure to include that little bar over the 4. And we're going to compare. So here we have 1 decimal value, and here we have 1 decimal value. So they have the same, but here's the issue. This one has a bar over it, this one does not. When it has the bar over it, means that that 4 is repeating. So if I was to write another decimal value, I'm writing a 4. Versus here, there's no bar over it, which means if I'm adding anything to the right, it's a 0. So now we're comparing 44 and 40. If these were positives, 44 would be greater than 40. But since it's negative, it's the opposite. It's going to be less than. Less than is to the left, which is this inequality symbol. Okay, number 10. Do they have different signs? We have a negative and a negative, so no. Do they have different whole numbers? Well, to the left of the decimal, we got negative 11. To the left of the decimal, we got negative 11, so no. We do not have different whole numbers. So now we actually have to do some work. I am writing down the full original number here as the decimal. And I'm going to look at the decimal values because we know to the left of the decimal is the same. We're going to look to the right. So this one has 2 numbers to the right of the decimal. This one only has 1. So I need this to have 2. I'm going to add a 0 so that it has 2. If these were positives, 81 would be greater than 70. An 81-year-old is older than a 70-year-old. But it is a negative, so it's the opposite. It is actually going to be less than. It's further into the negatives. Less than is to the left. Here is our inequality symbol. Negative 8 2/5 and negative 8 and 11 1/100. Do they have different signs? We have a negative and a negative. So no. Do they have different whole numbers? Well, the number next to the fraction is -8. The number next to the fraction is -8. So no, they do not have different whole numbers. Those are the same. So for our work, I'm not going to rewrite the fractions. I'm going to turn those fractions into decimals. So I'm just going to write -8 and a decimal point. And then I'm either going to use my resource packet or I'm going to use my calculator, and I'm going to plug in 2 divided by 5. And I get 0.4. We're not going to write the 0 because that's the whole number part, and we already have an 8. So I'm just going to write what's to the right of the decimal, 0.4. And now I'm going to do the same thing for this fraction, 11 hundredths. 11 divided by 100, and we get 0.11. So again, I'm not going to write the 0 because we already have an 8 to the left of the decimal. I'm going to write what's to the right, 0.11. And since what's to the left of the decimal is the same, I'm just looking to the right of the decimal point. In this one, we have one number. Here we have 2. So I need to make this 2 by adding a 0. Now we have 2 numbers to compare for each. So we're comparing 40 and 11. If it was positive, 40 is bigger than 11. A 40-year-old is older than an 11-year-old, but it's negative, which is the opposite, so it is less than. Less than is to the left. This is our inequality symbol. And one more. Do they have different signs? We have a negative and a negative, so no. Do they have different whole numbers? Well, the number next to the fraction is -4. The number next to the fraction here is -4, so no. So we're going to actually do work, but again, remember with those fractions, we are going to turn them into decimals. So I'm just writing our whole number, which is -4, and then in my calculator, I'm going to plug in 3 divided by 5. And we get 0.6. So I'm not going to write the 0, I'm just going to write 0.6. Now I'm going to do the same thing for 7/10. 7 divided by 10, and we get 0.7. So I'm not going to write the 0, I'm just going to write 0.7. Now I can compare that decimal value. This one has 1 decimal, this one has 1 decimal, so I don't need to add anything, I can compare as is. If these were positive, 6 would be less than 7, but since they are negative, it's the opposite, so 6 is going to be greater than 7. Greater than is to the right. That is our inequality symbol.